All right, period 3 and period 4. Like I told you, here's the video. You're going to notice me cutting in and out of the video a lot because that's me pausing. This is only like a 15-minute, 20-minute video, I think 15-minute video, but obviously class is a lot longer than that, right? About 35, 40 minutes. So the time that you might hear me talking and then it jumps over, or you might hear pencil sharpening in the background and then all of a sudden hear some voices. That's not happening in real time. That's me pausing. Time has passed and then I unpause and then we're talking about the stuff that we're doing in class. So you're going to have to navigate that a little bit because I'm just recording what we did in class, but I didn't record all of the class. I recorded just the times where I was talking or I was explaining stuff. So the times where the kids were working, I paused. That time is not recorded, so everything seems super choppy, but that's kind of the nature of the game. So follow along. I don't go over every question, okay? So that means I don't go over every single question, every single letter. I go over every number, like problem 67, 68, 69, 70, but there are parts of them I go over because those are the important ones. So you make sure you do the ones that I don't go over. Make sure you do them well and correctly. If you don't hear something or get something the first time, rewind or scroll back and hear it again, right? That's the benefit of video. In any case, homework is definitely due tomorrow. So you have 2 homework assignments due tomorrow. So the one that was due today, as well as the one you're going to do tonight for homework, and then due tomorrow, Thursday. All right. So good luck. Watch the video. Hopefully it helps. Bye-bye. Say hi, period 3 and 4.
Hello. Hello.
All right, so we're going to do the lesson. I'm just going to record us doing it. That's it. So that's all it is. Okay, more about slope. Which is steeper? Let's look at the first question. You guys answer it with your group together. Which is steeper? A line with a slope of 2/5 or a line with a slope of 5/2? Again, how do you know? Explain that. So talk about it, then write about it. Go.
Yeah, 5-2 is steeper because
All right, there's a couple ways we can say this. So give me one way. Give me one way. How do you know which one's bigger and why? Or which one's bigger? Harry. So which one's bigger then? Which is steeper? So you're saying this one's steeper, okay? And your comparison is that the actual value, 2.5, is greater than 0.4. Yeah, okay. Is there another way we can actually talk about this? Yeah?
the fact that 5/2 is, generally it tends to be bigger in the fraction.
Okay, so one way to look at it is that the numerator is bigger than the denominator, right? I'll just abbreviate it. So the numerator is bigger than the denominator, whereas this one's the numerator is smaller. So because the numerator is bigger, you have a fraction definitely bigger than 1. Here you have a fraction smaller than 1. So that's another way to compare. Whose rise is bigger? 5/2's rise is bigger. That's another way to look at it. If I've got 5/7 versus 2/... Actually, that's in the bad way. Don't look at it that way. I just messed you up. Don't say that. So this rise is bigger compared to the run. This rise is smaller compared to the run. So again, that's another way to look at it. Okay. So a lot of different ways. Let's go to 68. Compare the 2 lines in the graph at right. How are the 2 lines the same? How are they different? Again, observation. Go ahead and write what you think. How are the 2 lines the same? There's line A and line B, right? And how are they different? Just write about it. All right, let's talk about question B here. B says each line on this graph describes how much money a person has in his or her wallet over time in days. Now we're talking units, right? You see units here, dollars. You see units here, days. So now when we're talking about slope, you want to make sure you incorporate units like we did yesterday, right? I made a big deal about it. Those of you who finished classwork early, I walked around, I said you didn't write units. It's a big deal. You got to be able to use numbers and slopes and units for it to make sense. So explain what is happening to the amount of money each person has. Now, I don't need a number here. We're just talking about units. What's happening to person A's money in days? What's happening to person B's money in days? So write about that. Be specific, meaning talk about what's happening. You don't have to use numbers. Let's just use words for now. All right, what's happening to person A's money? What's happening to person A's money? Caroline.
It's increasing by $2 per day.
Oh, so you went specific. So you went $2 per day. So you're talking about the slope. So it's increasing. That's the key word. It's increasing every day, right? On the other end, what's happening to person B's money? Go ahead, Blake.
Decreasing 2 per day.
All right, so Blake says it's decreasing to, if you're going to say 2, you got to make sure you say $2 per day, right? So that's what we're saying here. So increasing, decreasing. So let's go back to question A. How are the lines the same? They kind of have the same slope, don't they? Like in terms of number, right? It's going up by 2, this one's going down by 2. How are they different? This one's headed up, this one's headed down, right? So obviously that's what makes them different. All right, so to describe how person A's amount of money is changing, the unit rate, that's when you divide them, okay, represents the amount that is added each day. Since the value of money is increasing, the slope is positive. But what should you do when the value is decreasing? How should the decrease be reflected in the rate? Well, how do we write decrease? So let's write each person's slope now. So A, you guys already said it, was $2 per day. That's their slope, and let's put M here for slope. So let's talk about person B then. How are you going to write their slope, knowing that it's decreasing $2 per day? Okay. How are we going to do that? Go ahead and write that. All right, what do we think? What do we think? How are you going to write that?
-$2.
Right, so it's just a negative sign. So you're going to put a negative $2 per day, right? That's all it is. Okay, so we already know what negative slopes are, but now we're using rates, meaning we're using units attached to that. So you may have positive, negative slope, positive, negative rates. Okay, and that does make sense because losing or getting things taken away is the negative process. All right, so question D. Remember that the slope ratio compares how the change on the y-axis compares to the change on the x-axis. Lines that go up from left to right show positive rates of change or positive slopes. Lines that go down show negative slopes. So we already found the slope, so let's not do that. I mean, we already did it, so let's move on. All right, here's where I'm going to leave you guys to work for a little bit, and we'll come back and we'll talk about it. Specifically, we're going to talk about line B, this guy right here. So let's work, and then we'll come back and talk about questions related to line B. Okay, so keep going. All right, you guys worked for a while. Let's talk about B. Let's talk about B. As the x value increases, so as x continues to go this way, so we're on question B. As x's move in time, days, what happens to my y values here? Stays the same, right? Or does not increase or decrease. Write that down, okay, if you haven't. Okay, so slope is a comparison of your change in y, so that's your vertical over your horizontal, or your rise and your run. Pick 2 points on B. How can you use the numbers? Well, if I pick these two, my run is a number, correct? Right? So my run is going to be a number. But we said the rise does not change. So what's the number for not changing? All right. So what's 0 divided by any number? 0. Now, if you just wrote this, you're half wrong. What do we need to incorporate with our slopes or our rates?
$0.
Units, right. So 0 what?
$0 a day.
$0 per day. Make sure you attach that if you've worked on it already, or if you haven't, you got to write this as $0 per day. Or you write it out in words, $0 per day. But in any case, you need words attached to these slopes because we are talking about rates now. Rates have no meaning if they are just numbers. Okay, words make meaning. Numbers represent the concept or what we're looking at here. Okay. All right, so now go ahead and do D if you haven't, and do the same thing. We need units attached to these slopes. So again, fix that if you haven't done that. A is a positive slope. C is a what kind of slope? Negative. Okay, now question E, I'm going to let you guys work on that. Unit rates mean just divide your fractions. In other words, no fractions, just decimals. Okay. Now, if it's a whole number or an integer, like -5, +2, then you leave it as that. But if it's like 0.75 or negative 0.25, then you would write it like that. And that's what a unit rate means. Include the units, right? That's why we call it a unit rate. All right, let's begin 70. Personal trainer. This is where we're going to revisit scatter plots like we did at the very beginning of our unit. And now we're going to actually find the slopes of your line of best fit. In other words, you're going to make sense of your line of best fit, attach a unit rate to it, the slope, right, in units, and you're going to make sense of the problem, not just graphing it and putting a line through your points. To prepare for biking long distances, Antoine has been trying to keep a steady pace as he bikes. However, since his hometown has many hills, he ends up biking faster and slower during different parts of the ride. Is this going to be a straight line graph? No, because he's got different times because of this faster, slower stuff. So it's not going to be a perfect line. To track the distance and time when he trains for the triathlon, Antoine purchased a special watch that tells him how far he has traveled at specific time intervals. You guys know what those are now. With the push of a button, he can set it to record data. Then at the end of his workout, the watch gives him a list. All right, so let's look at the problem here. On his first bike ride around town, he recorded several times and distances. These measurements are shown in the table. According to the table, does he appear to be traveling at a constant rate? So what you need to do is compare your rises and your runs, right? And don't just do one. Don't just do this right here. Don't just compare this side and this side. Okay, you would want to do a couple points. So then compare here to here. And then do one more like here to here. If it's consistently the same slope, then obviously he's traveling at a constant rate. But if it's not consistent, then obviously it's not constant. So figure that out right now. Is he traveling at a constant rate or not? Back it up with numbers. Back it up with slopes. All right, so here's how I would back it up. That's a 0.5 rise. That's a 2 run. So I'm just going to make a little slope. 0.5 over 2 is really 5 divided by 20, which is 1/4. Okay, so that first slope is 1/4. The second slope, that's a rise of 1. That's a run of 4. I get a slope of 1/4. They match. So you might be tempted to say, okay, that means that it's constant. Well, let's go to one more. That's why I took 3 points. This rise is 1.5. This run is 3. 1.5 over 3 is 15 over 30. If you don't know what I'm doing, I'm just moving the decimal, right? I'm moving the decimal right once and this decimal right once. What's 15 over 30?
1/2.
Okay, so that disproved the whole consistent or constant rate. You see what I'm doing here? So that's what you would need to show. If I ask this on a test, you would need to give me different slopes and thereby prove that it's not consistent. Yeah, we had a couple that matched, but we took one more set right here, and all of a sudden it's not the same. So that's what you use, right? Or question A, right? That's what you use, these numbers, to answer that question. So finish up that question right now. Slope is not a hard thing to do, right? It's just something that you need to be precise with. You have to count. You have to be able to figure out how far apart numbers are. All right, next, B. This is where we're going to spend most of our time, B, C, and D. We're actually going to combine B, C, and D into one giant question. So on this next question, put B, C, D together, and we're going to just make it one giant question, okay? Because there's no real point into breaking it down. Let's just answer it once. So B basically says, put 40 minutes on the x-axis, 15 miles on the y-axis. So do that now. Figure out some space on your graph paper on how you're going to do that. I would recommend the 40 minutes on your x-axis to go by 2s, right? So don't go by 1s, right? That's too big. I'd say go by 2s. So 2, 4, 6, 8, 10, 12, all the way to 20. And then for the miles, you would go by 1s on the y-axis because 15 spaces is not that big, right? So go ahead and do that. Then plot the points. Please label your x-axis and y-axis, okay? Label your x-axis, label your y-axis. If you're wondering what to label with, look at your table. They've got the x and y-axis labels right here. All right, let's draw our line of best fit now. So I've already prepared the data, obviously. You guys are graphing it. So let me switch screens here. All right, so here's my data, okay? I've tried to represent the axes that they want you to have, so that I went all the way up to 15 here on the miles side, and then here's your minutes, right? I went all the way to 40. So why do they want you to do that? Because they're going to have you extend this line. Okay. So I'm going to model drawing the line of best fit. The line of best fit, like we said, is a line. It's a straight line. So it's got to be straight. Grab your ruler. What I recommend is putting it down first and putting it up perpendicular to your paper. That means make it stick out so that you could see a straight line. Don't cover your data with your ruler. I'm going to cheat a little bit because I can. But your line of best fit is not going to start at your origin, because if I do this, that doesn't split my data well enough. It does split it right here in the middle, but notice I'm at the bottom and then I'm up on top and then I'm on bottom. I want to split it evenly. Okay? So my line of best fit is going to look more like this. Something like that. Does that make sense? You see how my y-intercept is down here underneath the origin, and that can happen. Later in this unit, we're going to make sense of that. We're going to understand if this makes sense or not, but for today, that's not our job. For today, our job is to make a line of best fit. Now, I know mine's not that straight. I had to use I didn't have a ruler on the whiteboard or smartboard, but you guys do. So it should be underneath, the y-intercept should be underneath, and you're trying to split it as much as possible, right? As much as possible. Also make it longer because I believe you have a future question you needed to answer, and so that's me making it longer. So make it go through the entire graph. Now there's a question C or D, I forget what it says. I think it says find how many minutes for him to something. Was it 10 miles? Does it?
Yeah. Or C or D.
Is it D or C? Something about find how long it takes for him to go 10 miles?
C.
Okay, so draw the line of best fit and figure out how much time it takes him to go 10 miles. So miles is on the y-axis. So we're just going to extend an imaginary line and figure out where it hits our line of best fit, and that's how much time it takes. Now, for me, it's around 30, a little bit above 30. For you, it might be a little bit lower or higher, depending on how you drew your line. So go write that right now. Put the dot right here. Put your coordinate right here. So you know your y-coordinate's going to be 10 miles. What's your x going to be? How many minutes? Right? It depends on you. It depends on your line. It depends on each person because you're drawing your own line. All right, let me hear some x coordinates. I got about 31, let's say. I'm estimating 31. Anybody else get something a little bit higher or lower? Caroline? 30.5, okay. Cade, what'd you get?
I got 32.
32? Anybody else? Yeah?
I had 34.
34. Anybody having something in the 20s? 29, 28? What'd you get? 29. 29? 28. So, we're pretty close, right? 32 was the highest, 28 was the lowest. So that's only 4 units off, or 4 minutes off. And because our lines are going to be different, that's the case. Let's continue on. If you have to go all the way up here, you have to do so. But find some lattice points and figure out your slope. You would draw a slope triangle to help you out. For me, my first lattice point would be right here. So I'm going to make it darker. And I'm looking and searching, looking and searching. Here's my second lattice point right there. So what I'm going to do is I'm going to find my slope using the rise, using the run. Do the same thing for yours. Make it a unit rate. In other words, divide it. Divide it. And I'll tell you what mine is after you figure out what yours is. All right, here's what I'm getting. 4 as my rise, 12 as my run. So my slope is 4/12, which is 1/3, and I said make it a unit rate. So that's going to be 0.33, and I'm just going to have to round. So I'm going to stop there because it's actually 0.3 repeating, right? But we don't write rates like this. So we'll just stop at the hundredths. That's okay. 0.3 miles per minute. So that means he runs 1/3 of a mile every minute. Does that sound reasonable? 1/3 of a mile? Okay. Okay, I don't know if that's reasonable. That's like a 3-minute mile. I don't know how he can do that, but
He's on the bike.
oh, he's biking. Never mind. He's not running. Okay, that makes sense. Plenty of sense. Woo! I got myself confused. That's why understanding the situation is important. What'd you guys get? Need some volunteers. What'd you guys get?
I just had the same as you.
Same thing as me?
2/5.
2/5, so 2/5, which would be 0.4 miles per minute, which is not too far off. Yep. 0.3 miles exactly per minute. Anybody get 0.2 something? No? Anybody get 0.5 something? Okay, that makes sense. 0.5 would mean a half, right? A half a mile per minute on a bike, that's pretty fast. And 0.2 would be too slow, like you're just not pedaling fast enough, right? So we're all pretty much in the same range, right? So that's pretty much it. Tomorrow we're going to interpret that, but today was all about that guy. That's why we did a whole bunch of stuff with slope. Okay, so we're pretty much done. I'm going to come around stamp classwork unless you're not done because we got about a minute and a half left, all right? Period 3 and 4, we're done. Bye.